What is a communist electrical system? Well, people have been asking me that for a while. And when I had to resurrect the communist electrical system to show some of these things, and maybe y'all can get your own idea about what's going on. But what we got is we got three phases from a three-phase alternator over here, powered by a motor, and the circuits set up around it are made from that gizmo with the three tapes across the coils. Those are two sets of Radio Shack mega cable speaker lines, 200 feet, and each of them 200 feet are 1/3 of the segment of the phase. And the phases, the way they're wired, they spiral around each other, and that shows a color code of how that's done. And the white spirals around the blue, and the red spirals around that, and so on and so on. Now, we also have secondaries, pancake coils, a single Radio Shack wafer, which is right underneath here. And we're going to show the position of the second wafer. There's the position of the second wafer. And we also have a third wafer. We're going to make that one a color blue, and we're going to make those two a color black. Now, what was going on here is each of them are secondaries around the peripheral poles of the 666 machine. And now what we're going to do is we're going to show what voltage is achieved on each of those wafers, and we'll start the whole machine up, powered by the motor. And we got voltage meters here. We got 3 voltage meters showing what each of them 3 secondaries are picking up, and each one of them's on a different color, facing a different color. But the one on there's the one facing the red color is on the bottom. You'll see that black checker underneath the red, one on top of the white, and then a blue checker on top of the blue. We got all 3 colors of all 3 phases of each inductor. That each of these inductors are going to receive energy. We'll turn the machine on. Here's our 3 voltages being obtained from the alternator. The lighting's not real good. I can't see what those are, but that's not real important. And here's the 3 voltages achieved by each of the 3 pancake Radio Shack main cables in series. Now, if you understand 3-phase, when we wired these things up, we never connect the phases between each other, but we have here. We got 4.85 and 4.7 volts. We're wiring them in series. So that we're achieving 14 volts. How in the world can this occur? Okay, now we look on the other meters here. Between the first 2 phases, they were measuring 4.9 and 1 volts. We got 8.9 volts, 9 volts fluctuating. And then between 4.8 volts and 5.1 volts. We need to get all these meters in the picture. We can use mathematics to determine the phase angles involved in all that. And we find out that our output, which we're not showing, right there, it's showing on the bottom, has 14 volts. There's just no logical way in time that could be happening. because one's a little over 120 degrees at a time, and the second one is about 145 degrees at a time, and we'll be able to show on the video the calculations of the relative voltages to show that's true. And then we want to see what kind of work it can do. Now we want to see what kind of work it can do. We're going to hook it to a transformer. There's the transformer, and there's the load. We're going to see now how the process changes when we add the load. And now seemingly we're powering the neon bulb that normally takes 500 volts to load from the outputs of the alternator, and we're going to close out here, try to show something else. The outputs of the alternator actually go up from the no load. There's the no load. We got 5.4 volts, 5.4, and 5.3. And there's the loaded state. And we also want to note the divisions of phase angles involved here on that operation. And it appears that we got 4.9 volts going into the transformer with 2 volts, 3 volts, and 1.6 volts. And also we got the relative voltages between those voltages, which will be assumed added up to 360 degrees of time. In this case, it may not, and this is what it's all about. We'll end it there, and there's our qualified output. Thank you.